James Webb Space Telescope vs. Hubble Telescope. Huge differences. The James Webb Space Telescope, JWST, is undeniably a significant upgrade from its predecessor, the Hubble Telescope. Therefore, it's clear that there will be distinct differences between the two. In today's video, we'll unveil the astonishing disparities between the Hubble and the JWST, and these differences are truly remarkable. Don't forget to subscribe to our channel to stay informed about the latest updates on the James Webb Space Telescope, NASA news, and other space-related developments. The comparison between the two, the James Webb Space Telescope and the Hubble Telescope, raises questions. Will the JWST live up to its hype? Much like assessing the qualities of two children by their parents, NASA faces challenges when contrasting the attributes of the Hubble and the James Webb Telescopes, JWST. Is the JWST meant to replace the Hubble? Or does it take on the role of succeeding the Hubble, carrying forward its remarkable legacy in a significantly advanced manner? The James Webb Telescope represents an exceedingly potent, exceptionally advanced, and costly endeavor by NASA. Nevertheless, this doesn't diminish the significance of the Hubble. The Hubble serves as the precursor to the JWST. The advanced features incorporated into the JWST are essentially an evolution of the improvements made to the Hubble. Disparities exist between the two, and at times, these differences are substantial. The Hubble telescope achieved success by unraveling various mysteries and anomalies of the universe. If you've watched our previous video, you're well aware of the captivating images captured by the Hubble. The structural and functional distinctions between the two telescopes are considerable. However, all the scientific objectives of the JWST have been shaped by the inspiration drawn from the outcomes produced by Hubble. Notably, the Hubble Space Telescope is named after renowned astronomer Edwin Hubble, while the JWST is named after NASA Administrator James Webb. The most striking contrast lies in the primary mirror's size. The JWST boasts a primary mirror with a diameter of 6.5 meters, endowing it with a substantial collecting area. In comparison, Hubble's mirror has a diameter of only 2.4 meters. This staggering difference means that the JWST has 6.25 times more collecting area than the Hubble. Consequently, the space images captured by the JWST are expected to exhibit significantly higher resolution and clarity. Furthermore, the JWST's mirror, constructed from beryllium, is highly segmented and comprises 18 hexagonal segments, each the size of a coffee table. These segments, coated with gold, effectively reflect infrared light. In contrast, Hubble has a single mirror segment, highlighting yet another core difference between the two observatories. Following the launch of the Hubble into space, a significant flaw was identified. Initial images were heavily blurred due to technical issues in its primary mirror. This issue was addressed with corrective optics, allowing Hubble to achieve a clear vision. Astronauts had to undertake 5 servicing missions to transform the Hubble into an optimal space observatory for capturing and observing various celestial phenomena. However, the JWST cannot be repaired or serviced. Positioned 1.5 million kilometers from Earth, it remains beyond astronauts' reach. Thus, the JWST's primary mirror is highly segmented to enhance its precision, as it cannot be repaired in the same way the Hubble was. Additionally, the JWST's expansive sunshield, roughly the size of a tennis court, aids in maintaining its temperature and preventing overheating, crucial for precision observation. In terms of technology, Hubble primarily uses ultraviolet, UV rays, visible light, and near-infrared wavelengths to study space elements. In contrast, the JWST employs near and mid-infrared wavelengths to trace the origins of galaxies, nebulae, and stars, providing astronomers with a clearer understanding of past cosmic formations. The Hubble telescope has been operational for 3 decades, deployed in low Earth orbit in April 1990. In contrast, the JWST was launched into space just last year in December 2021. This marks the culmination of the James Webb Telescope, fondly known as the father figure of the JWST, which sets a new milestone in space exploration. Let's see if the Webb Telescope outperforms the Hubble in a superior manner. Here's a fascinating tidbit. Have you heard of the South Atlantic anomaly? This anomaly has always been a significant issue for space satellites. It's a small disruption in Earth's magnetic field, affecting satellites, including the Hubble Telescope, as they pass through it. However, Webb won't be affected by this anomaly since it won't cross its path. This difference will enhance Webb's precision. Unlike Hubble, which orbited Earth at an altitude of 570 kilometers, Webb doesn't orbit Earth at all. Instead, it orbits the Sun. It remains stationary relative to the positions of the Sun and Earth. Webb's fixed position, wide sun shield, and distance from Earth will prevent excessive heating. This leads to more accurate observations and higher precision compared to Hubble. Hubble was launched into Earth's orbit via the Space Shuttle rocket, while Webb, not orbiting Earth, was deployed by the Ariane 5 rocket. Both telescopes allow astronomers to peer into the past, aiding our understanding of galaxy formation. Hubble focuses on young galaxies, while Webb studies newborn ones with more detail. Hubble provides insight into the universe's formation 12.5 billion years ago. Webb, utilizing infrared vision, delves even further, exploring entities from 13.5 billion years ago. Webb's edge lies in using infrared light to trace objects, especially as galaxies move away from us due to universal expansion. Longer infrared wavelengths easily penetrate dust clouds, revealing information about stars, galaxies, and nebulae. Webb's power is evident in tracing objects 10 billion times fainter than what Hubble can detect. It employs 4 advanced instruments: the Near-Infrared Camera, NERCCM, Near-Infrared Spectrograph, NIRSpec, Mid-Infrared Instrument, MIRI, and Fine-Band Sensor, FGS, with Near-Infrared Imager and Slitless Spectrograph, FGS and NIRISS. These tools enable imaging spectroscopy, allowing Webb to gather data Hubble couldn't. Webb captures clear images of exoplanets, clouds, nebulae, galaxies, and stars. It determines whether other planets can support life and searches for extraterrestrial existence. With Webb's capabilities, it's intriguing to contemplate its potential in unraveling complex mysteries and becoming a worthy successor to Hubble. Which contrast between Hubble and Webb intrigued you the most? Share in the comments. If you enjoyed this video, like and subscribe for thrilling updates about the James Webb Space Telescope, NASA news, and space exploration. See you in the next video.